Very good afternoon to one and all. Myself Sheikh Naseema, working as assistant professor in the Department of Computer Science and Engineering at Annamacharya University. Today I would like to give one small lecture on the topic A-star algorithm in the subject of artificial intelligence. Here, A-star algorithm is one of the best and popular technique which can be used for finding the path and graph traversal, and it is also considered as a heuristic search algorithm, and it comes under the category of informed search strategy. The real-time applications of A-star algorithm we can see in games and web-based maps, and it is essentially a best first search algorithm as it is providing the best path cost. It maintains a tree of paths originating at the start node and extends those paths one edge at a time. It continues until its termination criteria is satisfied. And here A-star algorithm extends the path that minimizes the following function, that is f of n equal to g of n plus h of n, where f of n is nothing but the estimated minimum cost value of the entire tree, and it can be evaluated with the help of g of n value and h of n value, where g of n is the path value from the start node to node n, and h of n is the cost value of the particular node n to end node, that is goal node. And every h of n value is connecting with the node, and g of n value is connecting in between the nodes. The implementation of A-star algorithm involves maintaining two lists here. First list is open and second one is closed list. Open list always contains the nodes that have been evaluated by the heuristic function. That means open list always contains the nodes that to be visited, or these nodes are also called as a waiting elements. And a closed list contains the nodes which already visited the tree, and these also called as a deleted elements list. Here the step-by-step procedure we can see. In the first step we have to define a list open. Initially the open list contains a single node because it have a start node s, and in our example we have considered start node as s, and after considering the open list, if the list is empty then we return the failure and exit the node. Otherwise remove the node n with the smallest value of f of n from open and move it to list closed. If node n is a goal state, then return the success and exit. Otherwise, expand the node n. If any successor to n is the goal node, return success and the solution by tracing the path from goal to start state, that is S. Otherwise, go to step 6. Here, step 6 consisting of for each successor node, apply the evaluation function f to the node. If the node has not been in either list, add it to open list because it has to be evaluated, right? And coming to step 7, go back to step 2 where we have to again repeat the same procedure. Let us consider one small graph. For example, here the node started always from the start node, that is root node. Consider here A as our root node and our goal state is J. In order to reach or in order to get the minimum path cost from start node to goal node, that is A to J, here we are applying A star algorithm on the particular graph. Because it is a graph, why it is a graph? Because it is in a cyclic way. So from root node or the start node, how many children are generated, that many children must be evaluated with the minimum cost value. For example, let us take here in this graph A is the root node and it is having two children, that is B and F. If I want to evaluate the value of B, first I need to know what is the g of n value of node B and what is the h of n value of node B. As we already discussed, the g of n value is the value that is generating from the start node to node n, that is A to B. The value is here 6, and h of n value is connecting with the node, or it is also considered as the heuristic value. In this case the heuristic value of B, that is h of n value, is 8. So in order to evaluate the f of n, that is f of B value, we have to add g of n plus h of n, that is 6 plus 8. The total value is 14. And at the same time we have to evaluate the another node value also. By comparing of all these two nodes, then we will finalize that which is the minimum path cost. So here see, A to F, g of n value is 3 and f of h of n value is 6. That is 3 plus 6, it gives you 9 value. Among 9 and 14, which value is the lesser one? That can be considered as the best path cost. So as we know that node F given the evaluation value 9 here, so we have to expand the children of this node again. That is, the children of F are G and H. Likewise, we have to evaluate each and every node's value so that we will finally get the best path cost, right? Here for finding the f of g and h of g and h of h values, here first we need to add the g of n and h of n value. That is 1 plus 5, that is 6, and here 7 plus 3, that is, wait, see, here from node f to g the value is not only 1 but also from a root node we have to calculate the value, that is 3 plus 1 plus 5. Here 5 is the h of n value. So the total value is 4 plus 5, 9 is the heuristic value of the node G. And here when comparing with the other branch, that is A to F, the value is 3 plus and 7. 7 is the G of n value, that is 3 plus 7, 10 plus 3, that is total 13. 9 plus 13, which 9 and 13 among these two, again which is the best path cost? G is the best path cost because it is providing you the minimum cost value. Again we have to evaluate the children or the next node of G. That is only one node is there, I. For this we have to evaluate the value. Whatever the value we are receiving here, that can be considered as the here minimum value. And from here again, how many children are there? 3 children generated. That is E and C. E, J and H again. Not only H but also G also connecting with I, but as we know, we already considered this G value as the minimum value, so we will just remove this H node and we will just compare with the G, E and J. By comparing all these nodes we will get like this. See, whatever we discussed, the steps here we are seeing. See, for the third step only I node is there, so for that the value is 8. After this we are seeing that 3 again nodes are there, that is branches or children of the I node. For these three, among these three we have to find which is the minimum path cost by evaluating the A star algorithm formula, that is f of n equal to g of n plus h of n. As here g of n value, see, as here g of n value, we can see for the E node 15, g of n, not only g of n, g of n plus h of n value. Total value is 15, 12 and 10. Among these three, which is the minimum one? 10 is the minimum one. So, with this we can conclude that our goal node J reached with the minimum cost value. That is what we have to find here, the best path of A star algorithm. We achieved here as A to F, F to G, G to I and I to J. See, it is only represented here in the graphical structure, highlighting with the red mark. See, A to F, F to G, G to I and I to J. So the best path cost here is the total cost and the path is AFGIJ. Thank you.